In this video, we are going to talk about intermolecular forces. It's presented by me and David. So here's my definition for intermolecular forces. The forces that are between molecules. It's pretty simple. This is just an overall viewing of what IMF intermolecular forces are. There are three types of intermolecular forces: dipole-dipole interactions, hydrogen bonding, and London dispersion. Dipole-dipole and hydrogen bonding have to deal with polar covalent bonds, and London dispersion has to deal with nonpolar covalent bonds. So just a quick review for nonpolar and polar covalent bonds. Nonpolar covalent bonds are when electrons are shared equally between the elements. Polar covalent bonds are when electrons are shared unequally. So let's look at dipole-dipole interaction. So this is an acetone, and if you don't remember what acetone is, this is the formula. So since oxygen is more electron negative, it's going to pull electrons from carbon, and it becomes more negative. Negative. And carbon, since it lost electrons, it's going to be positive. And if we have two acetones, and it looks like this positive carbon and this negative oxygen is going to attract each other. Oh my god, I need my pen. So this attraction between them is intermolecular forces, which is my topic. And you will need X amount of energy to break this intermolecular forces. For acetone, you will need 56 degrees Celsius to boil it. So let's look at hydrogen bonding. This is water, H2O. And oxygen is more electron negative, so oxygen is going to pull electrons closer to itself. Therefore, hydrogen become more positive. Same thing here, negative, positive, and positive. There will be some sort of attraction between this positive hydrogen and this negative oxygen, and this is intermolecular forces between them. So some people say, okay, they are polar and there's a intermolecular force, so it's dipole-dipole interaction. But in this case, this is even stronger version of dipole-dipole interaction. That's called hydrogen bonding. Hydrogen bonding is the strongest intermolecular force. So to recognize a hydrogen bonding, you need to see what hydrogen is bonding to. In this case, it's oxygen. So when hydrogen is bonding to fluorine, oxygen, and nitrogen, they will be considered hydrogen bonding, which you can remember as foam. And the boiling point for water is 100 degrees Celsius. This is higher than acetone's boiling point. Acetone's boiling point is 56 degrees Celsius. I mentioned it before. This is because the intermolecular forces between water is stronger than the intermolecular forces between acetone. So the bond is stronger. So you need more energy to break them.
Generally, London dispersion is a force between nonpolar molecules that have temporarily included deep dipole-dipole. It's a very weak force between attraction. It's not a constant. Here's a quick review question. Try to fill in the chart. The answer key will be shown in 3 seconds. And here is another quick question. What's the difference between polar and nonpolar? The answer will be nonpolar covalent bond is when electrons share unequally between elements, for example CH4. The polar covalent bond is when electrons are shared unequally, for example CO2. Thank you for watching our presentation. This is David and